Hello and welcome to PAVE's latest weekly virtual panel discussion. My name is Ed Niedermeyer. I'm the Communications Director here at Partners for Automated Vehicle Education. We have a fantastic topic today that's really fundamental to our monthly theme of understanding autonomous vehicle technology, and that is mapping. This is a topic that can oftentimes have some false familiarity because we as humans all have used maps before, but hopefully we'll be able to illustrate that how AVs use maps goes well beyond how humans does. I'm really thrilled to be joined by four amazing experts from really some of the top companies in mapping for automated vehicles. First off, from DeepMap, we have Vice President of Operations, Lucquet. Richard, welcome.
Thank you.
And from Mobileye, we have Vice President for Mapping and Localization and Co-General Manager for REM, Tal Babaioff. Tal, welcome.
Hello.
From Point One, we have CEO and founder Aaron Nathan. Aaron, welcome.
Thank you.
And from here, we have Sheila Nedelcu, Senior Director for Automotive Products. Sheila, welcome.
Thanks. Hi, everyone.
So mapping is an important, but also quite a diverse field. There's lots of different approaches. And so I thought I'd use this first question as an opportunity to not only allow you all to introduce yourselves, but to introduce your company and your philosophy to mapping. And we'll go in the same order. Richard, starting with you.
All right. Yeah. Thank you, Ed. Hello, everybody. Thank you, PAVE, for the opportunity to be participating in the panel. Very appreciated. So my name is Richard Lucquet. I'm managing basically the mapping operations and the map making for DeepMap. And a few of the key points that the way we're approaching map at DeepMap is, first of all, we're a map engine service provider. We're subscribed to our services like any enterprise software as a service model. So slightly different than just saying we're selling data. We're actually selling a service. We collect data from survey fleet as well as crowdsourcing fleets. And we offer a highly accurate ground truth map, which we call high definition reference, HDR. And in the spring, we'll be introducing our fully crowdsourced service on top of that. Two products work hand in hand. I mean, it's clear to us that crowdsourcing is really the only way to reach full autonomy. And this has been our vision since the company got created about 5 years ago. So our map engine creates and updates maps from any data source with any sensor capability. So we're basically sensor agnostic, which is one of the things that our customers really love about us. It doesn't matter if you're using a Velodyne LiDAR, a Sony camera, or whatnot. We're kind of like Switzerland, if you will, completely neutral to the sensors. And because of that, we're kind of independent. We're not tied to a specific chip maker or an automaker per se, which provides quite a bit of advantage. So that's kind of in a nutshell what how we see
Great.
mapping.
And Tal Babaioff.
Okay, thank you for the possibility to talk here. Mobileye is a company which is leading the camera ADAS business. We have been putting cameras on vehicles, on more than 65 million vehicles over the years. And when we came into mapping, we came into the approach of having crowdsourced approach coming from a camera. So without needing to put any extra hardware on the vehicle, we are able, using our cameras as an ADAS vehicle, to collect data over 3G in a very compact way, 10 kilobytes per kilometer, get all this data together and be able to create AV maps, which are used for any L2 plus or AV application.
All right, and Aaron?
Yes, so thanks for having me. Appreciate it, Ed, and PAVE here. And so just to introduce Point One, we are a slightly newer company than Mobileye, but we actually believe in a very strong and slightly different perspective where we create maps in what we call the absolute frame. And what we've done is empowered our customers to be able to create their maps by combining really the powers of both computer vision types of applications and satellite navigation. And so this is a lot of the core of what we've built as a company. And really, we believe very strongly that the crowdsourcing is going to be one of the key ingredients in order to make these maps scale and to keep them up to date. And that the technology we bring to the table allows us to do that with the almost 17 million cars a year being sold here in the US and even more abroad.
Great. And Sheila.
Hi, thanks for having me. So here is really a location platform company at its core. We have essentially instituted a service-oriented architecture in our map making as well. And we believe in using all the data sources available to us. I think the benefit that we kind of bring to the party is, 20 years plus of map making and over tens of thousands of data sources that go into making our maps. I agree with what Aaron and Tal said, that we believe that OEM sensor data or crowdsourced data is absolutely the way to keep your map the freshest, but we have adopted a way of conflation to conflate multiple data sources to be able to scale and essentially provide global coverage of HD maps. And really leveraging our platform where people can come and bring in their sensor data, and not only we can use it for making our maps, but they can actually monetize it themselves for other reasons.
Yeah, so you all have already said so much that I want to dig into here. Richard, I want to start with you and sort of get into the issue. You talked about crowdsourcing and a survey, fleet mapping. And we're talking about sort of the term HD map gets thrown around a lot. Could you just talk about the different approaches you mentioned? You use both crowdsourcing and survey. And in terms of like the definition and the quality of those maps, right? So you have like different ways to, millimeter accuracy, for example, or centimeter accuracy. But then you also have sort of like updated, how fresh a map can be. So you have lots of different sort of measures of quality. Can you talk about the different approaches and sort of how they, and I'd like to get everyone's sort of perspective on this as well. Sort of what is the relationship between the different approaches to mapping and sort of the different kinds of quality that a map can have?
Sure. So we call our map HDR, high definition reference, and the reference is key there. It's both in accuracy and in detail. So you really have to consider the many criteria of a map, right? It could be accurate, precise, the recall, the freshness of it, the geometric accuracy and the precision must be really high to support safety, robustness, high performance, and even comfort of the drive, right? But at the same time, the completeness of a map it could be interesting. For example, in our map, we provide a feature that defines the navigable boundary of a map. So it's not only the lanes, but it's up to where you can go safely if you have to, right? And it's quite important for full autonomous vehicle to know when it, in case of an emergency, it needs to stop or whatnot, to know where it can drive, even if it's not a legal lane. So those are the kind of things that we add as far as completeness to the map. As far as accuracy, I mean, you mentioned whether it has to be globally accurate or not globally accurate. We believe it's extremely important to have a global accurate map. When you start having many sensors that are trying to figure out localization, and I think Aaron would not disagree with that, with one of their products where they're basically deploying a lot of base station all around so that you have a way to know very accurately where you are. It's quite important to know where very accurate all of the features in the map are to the same reference. So we believe that all of that is part of HDR, and HD as just HD is just not enough. You got to have a reference for the map. And it's also super important to conflate all of the data that you receive from all the various sensor or different data source. You need a reference to base to in order to align everything together.
Yeah, and I want to get Tal and Sheila in here, but Aaron, let's go to you real quick since he just mentioned something related to what you do. Could you just sort of add your perspective on that?
Yeah, for sure. I mean, so this is actually probably one of the unobvious things in mapping is that there's really two ways of thinking of a map map, and there's absolute frame that Richard brought up here, which is something we very strongly believe in, not only from a technical perspective, but actually from just the way that systems need to interop with each other. In a real deployment, you can imagine an OEM picking a different map provider for different regions just based on who happens to be in Japan versus in Europe versus the US. And it's very important that we all speak the same language. And in mapping, this is really the coordinate system that ties everything together. And so we've gone through great pains to make it so that the vehicle can know very accurately where it is on anyone's map. And when we talk about that, that's 10 centimeter, like, roughly the size of a baseball level accuracy. And so, this is core to really what we do on the what's called localization, or basically, the blue dot problem, as I like to call it. Now, in terms of building the map, it turns out that if you know where you are very accurately, it actually helps with the crowdsourcing. You can kind of think about it as like the power of the information behind every vehicle that's driving around is effectively like amplified, because now I know exactly like where that camera or LiDAR or radar or whatever the sensor is was actually pointed at that time. So, I mean, our perspective on this, frankly, is that the absolute frame makes it so that everyone can kind of be in that same conversation. And then, eventually we're going to have even what I like to call superhuman capabilities with autonomous vehicles. This is where vehicles can communicate to each other even beyond the visual line of sight. And so if there's an accident coming up and it's like 4 cars ahead, but everyone's at a dead stop, you'll be able to know that in your AV and not have an incident. So ultimately, the absolute frame there is really important so that we're all talking the same language, all working together. And I would hope that that's, something in the mapping community before AVs, it was a really important core value.
Absolutely. And Tal, I know Mobileye had a fascinating conversation with your CEO not that long ago. You all have really gone in on the crowdsourcing sort of approach to this, right? Can you help people understand sort of why and why that approach?
Yes. So Mobileye came up to understanding that if you don't have maps wherever you want to go, and if your maps are not updated fast enough, then you don't have a map. You cannot rely on that map. You cannot work with that map. And we need a map that we don't have to survey in order to create it. And we don't need, and this map needs to be valid and continuously updated. And the way we selected to do it is based on millions of vehicles driving around and collecting us data in a very efficient way. This gives us both eyes on the ground, which validate our map all the time and allow us to identify changes. Because we are building on this simple agents to create the map for us, to collect the data, to create the map. We don't just understand that there is a problem and need to send a survey vehicle. And because of this also, we can also have a business case which makes sense. We don't put very expensive hardware on the units to collect the data. We sustain GPS, normal GPS, very not accurate GPS. It gives us the ability to work on local accuracy, not global accuracy, but we found it to be good enough. If you are in a centimeter accuracy and you have a region 100 meters around you, which you have everything accurate to a centimeter, this is good enough. You don't really care to the fact that you are not globally aligned.
Yeah, absolutely. And Sheila, you mentioned sort of using a variety of data sources in your efforts. Are there certain applications or functions that sort of more accuracy versus more sort of constant refreshing, where that trade-off comes in, or sort of how do you see the pros and cons of those two?
Well, I think first of all, I feel like I hit the jackpot, right? Like, so I've been building a map for 20 years. So this spine that we're all talking about, the super accurate spine, I already have. And I'm able to use all these other data sources to be able to snap to that spine. But I think it really is what we call a feature by feature, attribute by attribute question, right? Like, how often do I need to update a bridge? How often do they change? They usually only change if there's construction. So do I really need to have OEM sensor data feeding me every single day a bridge, which a camera can't even see in many cases, right? So, what we found is there's different data sources for different features to keep them fresh. And there's some features, and in our experience, we kind of understand real world rate of change. that we don't have to be updating our map every single day, but there's certain features that mean more to AVs, and there's certain features that mean less to AVs and that change less. So we use all the data sources coming in, and we're able to update our map, using the variety. So that's really been I would say our strong point, and the fact that we're able to scale. And I think that's going to be one of the issues. And I think, when we think about L4, L5 vehicles, nobody really cares because they're operating in very small ODDs right now. They can build their own maps. But when that starts to become hey, I want to go launch a fleet of vehicles in Atlanta right now, who can provide me a map versus sending my very expensive AV out there to go map it, we will have the edge there.
Yeah. Well, I feel like I won the jackpot because you just segued perfectly into my next question, which is about sort of the different things that you can do with the map, the different things that mapping can do for different kinds of automated vehicles. And I'd also like to make sure that we're keeping this open to include, as you've also sort of alluded to, driver assistance systems, conditional autonomy, all the way through level 4, even potentially level 5. Richard, I want to start with you on this. As I mentioned at the top, right? People use human maps to localize to some extent, but to figure out where they're going, right? But there's a lot more that automated vehicles can do. What's one of them that jumps out at you as something that people might not know about?
Yeah, so I guess one of the example, at least from from the services we provide, we not only provide a map that has all the semantic and the feature attributes of here are the lanes, here are the stop sign, here is the traffic light you need to look at. I already mentioned we offer navigable boundaries as another way to look at stuff. But another thing we provide is actually a fully registered 3D point cloud that is segmented, that combined with a precise localization system, or going back to that, can dramatically help the change detection and the overall behavior of the AV system, because now all of the sensors and all of the features of the vehicle that are sensing stuff, right, are able to compare that not only to semantic features, but also to physical artifacts around the area. And this is something that our customer find very useful in just another way, as another, I'm going to say something everybody's saying, mapping is another sensor. Our maps are providing two sensors. It's providing a 3D point cloud registered sensor and a semantic sensor that the AV system can use to navigate the area. So.
Yeah, and Tal, I want you to pick whatever function you want, but I was just really fascinated when I talked to, again, your CEO, Amnon Joshua, talking about how quickly you were able to get level 4 autonomous vehicles testing up in Munich, and he gave your REM mapping system a lot of credit for that. Again, feel free to talk about something else if you like, but that was just struck me as something that I didn't really fully appreciate.
So Mobileye benefit from the fact that we develop in-house our AV, and this is where we came up for the need of maps, and we have a tight synergy between map development and AV. We have today Israel as a sandbox, and Amnon is not driving his Porsche, he's driving a Ford Fusion, which is giving him point A to point B navigation and driving without touching the steering wheel, all the pedals, based on our AV technology on a RAM map. And this map is updating on a daily basis. Today, due to COVID, there is a lot of construction going on, and without updating the map every day, he cannot drive. We have set up AV driving in Munich and in Detroit, and we have done it from remote without sending engineers. And the map was created without sending a single vehicle to survey or to drive there. And we, among everything, because of crowdsource, we understand how humans drive. And this gives us a lot of insights which we can encapsulate into the map. Where do you have to stop on a stop sign? Where do you have to stop before entering a roundabout? What speed you should drive on the ramp? All of this is something which is not easy to derive from the geometry itself, but once you have a lot of crowds and you can derive these implications from it, you can actually give the AV the understanding of what a human would have done in that situation.
Yeah, and Aaron, what's something that how does localization, really high quality localization, how does that make AV development easier or allow an AV to function better?
Yeah, I mean, I would argue that it's one of the first problems that every AV company has to deal with when they're developing their stack. And I say this having personally built 2 autonomous vehicles myself in my career. And the reality is that, there might be one outlier in the industry, but other than that, localization is core, because I think, as we all agree, mapping is arguably one of the most important sensors to get right, because it gives the vehicle this notion of what to expect even before it sees it, regardless of if it's with a laser or a camera. And this is a really, I think, fundamental piece of why, I mean, our core market is actually the level 2+ and up vehicles. And this is really because what we're starting to see are the limitations of really pure, we'll call it like reactive sensing with no kind of prior about what the environment looks like. And once we start to incorporate that knowledge ahead of time of, this is how many lanes there are in the highway, this thing on the right is an exit ramp, not having to perceive that in real time, but actually just be able to look it up, which is really what a map does, that really changes the end user experience. The level of confidence that I feel when I sit in that seat and that steering wheel is moving itself, it really comes from the fact that, the AI under the hood actually knows that, hey, this is what's coming, and I don't have to have perception, really deal with that. Now, of course, like, there are exceptions. There are things like construction zones and, all kinds of random things that happen. And so we still absolutely need robust perception for those. My core belief, though, is that we can solve these localization problems using actually the sensors today on vehicles, deliver like a step change in the capabilities that we see in today's kind of level 2+ systems. And frankly, the likes of, the Cadillac Super Cruise system, as an example, really have already demonstrated this. They're one of the first that really brought an HD map in the truest sense to market. And I think that's just the beginnings of what you're going to see rolling out, with Mobileye's RAM and other folks that are really trying to bring localization and mapping into the actual core market segment.
Yeah, that's a great example with Cadillac Super Cruise. And Sheila, sort of what do you see as sort of maybe unintuitive or just less well-known sort of way in which high quality mapping can really improve the performance of any kind of automated vehicle?
Yeah, and I think it's been interesting for me because I'm working with so many OEMs, and their reliance on their map based on their use case is so different. I mean, the use case really drives the reliance on the map, and also their AV setup, right? Their automated driving system has different levels of reliance on that map. But everybody's kind of said localization, as like kind of redundant system. So if I had to pull something out new, I would say route clearance is a great one, right? What roads should I be driving on? I think, if we look at some of the accidents we've seen in the past, some of this functionality has been triggered by users on roads that should never have been used on. So we absolutely, provide route clearance capability, as well as, when we're looking at the L2+ use cases, and we've absolutely seen a transformation from our customers to understanding the value in the map for those functionalities. It's just a better user experience, right? When I think about lane keeping assist, for example, in really bad weather, all of a sudden I can rely on my map and that function can continue to work. So, and me being a driver, I'm always like, why does it work now and why doesn't it work then, right? So it's more consistent user experience. I think many of our customers has realized the value of an HD map there for sure.
Yeah, we got a number of questions from a number of companies, from Ford, from InterDigital, kind of about the format and potentially cooperation. And this is something I will happily admit I know nothing about. I'm really curious to hear you all. I actually like to go in reverse order so we can mix it up a little bit. So let's start with you again, Sheila. Sort of what kind of formats are maps in, and like how much interoperability and effort at sharing is there?
So I think that's a kind of a two-pronged question for me, because we're getting a lot of pull from the market to have our navigation maps work with our HD maps. So when we think about our navigation maps, those are really human interpreted maps versus man-machine maps. So a lot of pull of, hey, I want the human to understand what the HD map is doing, driving autonomous features. And right now those are kind of mixed formats, and how do they come together? The second thing is when we look at SIM, right? The SIM people out there that are trying to play on SIM are really looking for different kinds of formats. So from our perspective, we just build content and we will produce it in any format you want to. And we for sure have adopted the NDS format, which is an industry format that's been accepted by the automotive industry that allows them to plug and play providers. So I would say it's a mix out there between proprietary and standard that's still going on, and we're trying to support all of them.
Yeah, and Aaron, you're using different kinds of sensors. You're working with different companies. Is this a big challenge? This interoperability, this compatibility issue?
Yeah, I mean, it certainly is. Just in the early days, I think of any technology, there's a lot of varying approaches, and people are moving quickly. So standardization kind of is happening almost by accident than by force. And the reality is that I think there are definitely interesting, open standards as well that we've started to see come out of some of these community projects that frankly are now making it into these level 4 and level 5 systems. Lanelet 2 is like an example of that. And we see that really also in the SIM world becoming very prominent. The other side of this is that, I mean, even more fundamentally, the way that we talk about location, frankly, is not even standardized yet. Like when we talk about, everyone thinks, oh, it's a latitude and longitude that defines a point on Earth. That's actually a really complicated thing there. And this is something that in the GIS world, where people are surveying roads for construction, I mean, there's a lot of infrastructure and standards that I think that the HD mapping community are going to borrow from and learn from. And this is something that, is a world that we kind of span, just given the fact that we have, the deep experience in GPS as well. So we'll see. I mean, I think it's a very rapidly evolving system as we start to see the scale of the maps exceed just like a small city and actually move out to, we want to now have an HD map that's, the entire US freeway system. Those are very difficult things to make consistent. And but the standards do exist. It's just a matter of time of getting them to actually be adopted widely.
Absolutely. And Tal, you, as you mentioned, you have one main client, right? Mobileye. So I imagine sort of working with other suppliers and stuff is not as big of an issue, but maybe are there other like business models and things that come out of the mapping work that you do, primarily focused on, and again, this AV program, but opens up all kinds of possibilities when you have that kind of map, right?
So it's worth to say that we have few L2+ customers, OEMs, which are adapting our technology and using it for improving their ADAS and doing better lane centering and so on. We do want to have an interface which is very beneficial for them, but very efficient, and we tailor-made it. And yes, we can package our data in various programs, various ways. We do see real value because we have so many agents looking on the world for us that we can actually find interesting data points and be able to monetize them, like giving you ability to monitor the quality of the road, find cracks and potholes before they emerge or when they start, and allow maintenance for that, allow predictive maintenance from various sides based on facts that the camera do see. And this is already becoming more and more relevant today for us.
Fascinating. And Richard, would you like to give your thoughts on interoperability or sort of the different business models that this opens up?
Yeah, so I mean, what we're seeing from OEMs is that they're seeing mapping as core to their AV system. I mean, as we've established by now, mapping is not an afterthought. Mapping is basically the foundation of a solid, safe, and a comfortable AV system. So most of the OEMs are basically looking at keeping that in-house in a way, but without necessarily the burden of developing the tools to do it. So we see ourselves as the tools provider for OEMs to build their map and maintain it, and being able to have, as a few, I think Tal mentioned that, Aaron too, in a way, mapping and perception and control are a very tight coupled system. And when are we getting to a point where you can separate them very easily and have a very standardized interface? I think is further down the road. I mean, eventually we'll get to that. I'm hoping we get to a system where I can buy a BMW with a Porsche driver, and I can just sit in the back and enjoy it. But we're not at that point yet. So we're not at the standard 3-pedal system. for robots. So in the meantime, we're really a strong believer that we're providing all the tools for OEMs to design it, and from a format point of view and interoperability, we're basically exporting to every format there is out there, because every customer has their own way of doing it, and it's typically a different format for simulation, that is a different format for driving, a different format for visualization if they want to visualize stuff. So we're pretty agnostic to all that.
Yeah, I just love all of the different perspectives we've been able to get here today. It really helps give you such a broader picture of this fascinating and quite complex world. That is unfortunately all the time we have right now for this. However, we are going to be continuing the conversation with a number of our panelists here over on Clubhouse. So if you go and open your Clubhouse app, we will be jumping on there in just about 5 minutes. So please come there. We have a bunch more questions that you asked and that we prepared that we haven't really had time to get to. We'll get to some of those, and once we're there, raise your hand and we'll try and get your questions as well. Thank you so much again to all of our panelists. Again, just the variety of perspectives we're able to get here is really, really fantastic and really helpful. So Richard Lucquet, DeepMap, Tal Babaioff, Mobileye, Sheila Nedelcu here, Aaron Nathan, Point One Navigation. Really appreciate you all giving your time and your expertise. And thanks for being here. And I will see you over on Clubhouse in just a few minutes.
All right. Thank you for having us.
Thank you.